Okay, welcome to our session here. Thought we heard some music going on there. All right, congratulations. You made it to halfway through reInvent. That's quite a task. So this is going to be the best session you've had so far, so I hope you're excited for it. Certainly we are. Before we get started, I'd love to just know a little bit more about who's in the audience. So raise your hand if you're either a data scientist or a machine learning engineer. Okay, it looks like almost half. That's great. What about folks that are maybe in IT or operations staff, maybe working with ML platforms? Okay, maybe a little overlap and maybe the other half of the crowd. What about business leaders? Any CIOs out there, CTOs, head of data science? Awesome, okay, great. And then last bucket, anyone here in a finance role, maybe a CFO, somebody worrying about the cost of machine learning? Seriously, not one showed up. Okay. Excellent. Okay, so we've got a great topic for you that cuts across all of those roles, and I'm really excited to dive into it with you. I got started in AI back when 640K of memory and floppy disks were an interesting thing. They were keynote, highlights. You couldn't really do much with AI at the time, so it was kind of next to impossible, but a lot has changed. A few major things have changed. One is obviously the cloud and compute capacity on demand. So you can spin up hundreds of GPUs in a few minutes and do whatever you want to. Pretty amazing, right? Another big thing that changed is massive amounts of data. I didn't know what a zettabyte was recently, but it's 1 billion terabytes of data. So we've moved on from just relational databases and structured data. Now we're looking at documents and videos and voice, and even EKGs. Any data just about in the world is now accessible from machine learning models. So a huge shift in the amount of data available at really low cost. And the third thing is things like Python and open source frameworks and algorithms for writing machine learning models. So there's a lot less that you need to invent. So you can build on top of that really quickly and get started really easily. So what has happened is now machine learning is happening everywhere. Companies in all industries are making new products, more intelligent products, even disrupting entire industries. It's probably the biggest change I've seen, and I've been at technology for 30 years now. It's pretty amazing. So the conversation about machine learning, though, is changing. So even just a few years ago, most of the companies were thinking, hey, is machine learning really going to work? Can it really solve problems? And after a few successes, that has shifted to more, okay, how can we scale this out? How can we do it across our whole company? And just in the past year, we're seeing a lot more discussion of how do you actually scale at the right cost point? So how do you do cost-effective machine learning at scale? So hopefully you're in the right room, because that's what we're going to talk about for the next hour. My name is Mark Roy, and I'm a machine learning specialist, SA, at AWS. And we've got Mohammed Jamal here, the head of data science at Aramex International. He'll be joining me as well. And here's our agenda. We'll talk about the requirements for cost-effective machine learning at scale. And I'll introduce a framework that you can use to look at the total cost of ownership, which is how I think you need to look at this problem. I'll also talk about SageMaker as an overall end-to-end modular service, and what are the cost advantages and productivity advantages you get from SageMaker. And then I'll hand it over to Mohammed, who will take you through a case study on how Aramex is taking advantage of SageMaker. All right, so let's look at a few requirements. We had a few different roles represented in here. Actually, if we start with the data scientists and machine learning engineers, what I hear is, please don't make me do anything with infrastructure. I really want to build models, right? So they don't care about infrastructure. They don't want to have to build it. And typically, they're pretty expensive, and you probably don't want them building infrastructure either. And then we've got folks that are more into operations and infrastructure and providing platforms to these teams. They have to worry about that. But they want to do it in a secure fashion. So we've got to provide the data in a way where we'll dive deeper into security. But security is a big piece, as well as utilization. So we're spending a lot of money on infrastructure. Let's make sure we're getting the full utilization and not wasting any money. And they want to provide these services to these teams that are building the models. And then if you've got your CTO hat on, or your CIO or CEO, you're not just worried about the technology and cool models. You actually have to deliver something, make a difference in the bottom line, but also do it cost effectively. So business outcomes and cost effectiveness. So I think most of you out there either are in the process of adopting a platform, or maybe looking to figure out, should I build one, should I buy one? So how do we proceed from there? The way I look at it, you can either build your own platform, or you could use a managed service like SageMaker. If you want to build your own, there's a lot of options there on AWS. So you could use things like EC2. You could use our Elastic Kubernetes service, and those are a great starting point. From there, you'll need to integrate a whole number of different technologies that you could probably find out there, and build your own custom tooling, and put together something that'll probably work pretty well for you. Definitely a viable option. You'll have to worry a little bit more about security than you might otherwise. But one of the big differences as well is you're going to have to manage that. So you'll have to put it together. You have to make sure the lights are on, and you have to make sure that you maintain that over time. Contrast that with SageMaker, where you're just paying as you go. We take care of all of that behind the scenes, and it's a managed service. So I promised you a framework to think about cost effectiveness, and this is how I like to talk about it with customers. First of all, make sure you look at the entire process, so building, training, and deploying models. But then there's a few different dimensions to think about for cost across each of those. The first one that comes to mind is infrastructure, right? So what's the cost of the compute or some clusters that you're putting together? But don't be fooled into thinking that that's the most important thing, or that's where the discussion ends, because that's really just one element of it. It's the cost of the compute, it's the utilization, things of that nature that you need to think about. And then you need to worry about how much am I spending on operations. So this is people. It's tooling and it's maintenance of code and so forth, but it's people managing that environment, monitoring it, worrying about the health of it, and that costs money. In fact, that'll end up costing you more money than you think. And the last piece is security and compliance. So you can't do these things without really focusing on security, and in some industries, compliance is a pretty big deal, and we'll talk about that in a minute. So I think you want to look at it in this overall total cost of ownership view, and we've done some of that analysis on our own, and what we found looking across a whole bunch of different use cases, different size companies, different numbers of notebooks, different kinds of training workloads and deployment workloads, and we've seen anywhere from 50% up to 96% lower TCO. So you need to think about that as you're figuring out where to go with this. And that above and beyond that is the productivity gains that you get from all the features that SageMaker gives you to help those data scientists and the machine learning engineers build more quickly and iterate more quickly. So let's take one element of that framework. Let me just talk briefly about security. Amazon has best-in-class security capabilities for machine learning environments, things like end-to-end encryption, network isolation, authorization of using notebooks, doing training, hosting models in production, all kinds of logging and audit trails. Everything you would expect at all of those phases is built in from a security perspective. Let's take an example quickly so I can show you what I mean. Let's look at how secure training works at a high level in SageMaker. On the left, you've got this SageMaker VPC. That's what we manage. In the middle, we've got the customer VPC. That's where some of your resources will be. And then we've got other services in the cloud. Here we've got both VPCs exposed to the public internet. That's probably not a good thing, so we cut that off. When you bring your training and test data, you can store that in Amazon Simple Storage Service, S3, and you can secure that, you can encrypt it using a customer-managed key. And then when you start up a training job, SageMaker will launch instances inside of its own VPC. Your data will be securely transmitted, encrypted in transit using a VPC endpoint. None of this is going over the internet. That is also encrypted on the instances for the training. And you can turn on encryption for internode communication as well. So if you've got a distributed training job going on, even the parameters that are being passed between nodes, that can also be encrypted. When your model's done being built, that'll be stored back in S3 and also encrypted. And then we throw away those instances. So it's a really secure environment. We could spend another few hours talking about SageMaker security, but the point here is that this could cost you literally hundreds of thousands of dollars to add to your own environments. So if you're building up your own infrastructure, you've got to make sure that you address security. Some of you I know are in healthcare. I talked to a couple of folks in the front row here before the talk. If you're in healthcare and life sciences, if you're in financial services, a lot of highly regulated industries need the kind of compliance certifications that we're showing here, and SageMaker does that for you. If you're going to do that on your own, you know it's going to cost quite a bit of effort and money, not just to build it, but to maintain it, and we're listening for new requirements to extend this as well. So we've talked about security and compliance. Now let's talk about operating the environment. So here we've got a team of data scientists. We've got some folks that are worried about the operation of the platform, and you're spinning up some instances for running Jupyter notebooks, maybe some more instances for doing training, and then deploying your models maybe in batch or real-time endpoints. And at a small scale, maybe that's not too big of a deal to manage, right? What you'll find is that even at a small scale, SageMaker will give you some big advantages here. In fact, I've worked with a lot of customers where they don't even have any staff devoted to managing an environment. So they're able to get small teams in a self-service kind of mode using SageMaker and deploying things without any management of servers. And so that's a pretty compelling story. Now, what happens as you scale this up and you get larger and larger teams? You know, it's no longer just a few instances. You might, if you're going to manage this on your own, be prepared for hundreds or thousands of instances. Maybe you're managing clusters and you're trying to figure out, well, how many clusters do I need? You know, and hey, what instance types should I make available? And on and on and on. And then you've got to worry about availability of those environments and patching and so forth. That can get pretty expensive, let alone the utilization. So if you're managing your own environment, a lot of customers will talk to them and will find out that they're only using 25% of what they've provisioned. And so you're wasting significant money. You'll see with SageMaker that you get 100% utilization when you're using the training service. Because as I showed you the example, it's just spun up, the training is done, and then they're released. So you've got to worry about a lot more things as you're managing this, and you'll end up needing more people, more hands on the keyboard to do this. It may not sound like a big deal, but even if you just had a team of 3 people doing this, and you look at that over a 3-year period, that could be $1 million in total cost of ownership. So let's take a quick look at SageMaker at a high level, and then I'll talk you through some features at each of those phases of build, train, and deploy, and we'll look at how you've got cost savings as well as productivity advantages. There was a lot of announcements yesterday, I guess it was, about machine learning in SageMaker. This is at a high level some of the capabilities that you get, and I'll talk you through a number of them today. We could spend a couple of hours going a lot deeper, but I'll try to highlight the ones that are most important as you're trying to figure out, do I want to use a managed service or build my own platform? So here's a few of the things that I'll talk about. So on the build side of things, one of the things that is really exciting from yesterday is something called autopilot. So I'll take you through what that means. We'll take a quick look at fast start shareable notebooks as well, and experiment management. We won't really touch on labeling workflows, but that's a big cost saver as well. And the fact that you've got built-in algorithms and the availability of a machine learning marketplace is also a big win. On the training side, we'll talk about spot training, managed spot training, distributed training overall, and just the benefits of having a distributed training service out of the box. There was also a debugger introduced yesterday. That'll provide some definite productivity boosts. And we're a multi-framework environment. We're not saying, hey, MXNet is the best or TensorFlow is the best. You bring whatever framework you'd like. All of the major ones will be supported. And that's important because most data scientists use more than one. And then last piece that I'll talk about is deployment. And we'll talk about a few features there. One is multi-model endpoints. We'll talk about model monitoring and just the benefits of fully managed hosting overall. In addition, if we had more time, we could get into elastic inference. We can talk offline about the benefits of that. We'll hit on elastic scaling, and batch inference is important as well, and that's all built in. And then lastly, we added SageMaker Studio, which is the first machine learning workbench to tile these things together and make your teams more productive. Okay, so let's dive in for the next 10 minutes, 15 minutes or so. I'll hit each of these, and you'll see how these things contribute to the TCO framework. So first of all, autopilot. This could be a real game changer in a lot of companies. It's something where you can get started really quickly, automatically create regression and classification models on structured data. And it's not a black box like some of the other providers might give you. We'll give you a generated, commented, documented notebook where you can see exactly what's behind the model that was built. Let's take a closer look at how that works. So, of course, you start with training data, and you just put that into S3, and you identify, well, what am I trying to predict? Let's say I'm predicting the price of something. So you identify your data set, tell it what you're predicting, and then you say, OK, autopilot, do your thing. It will analyze your data, understand what the columns are, what the data distributions are, what transformations might be needed, and then it will automatically do some feature engineering for you. You don't have to worry about one-hot encoding and normalization, maybe doing some things with date columns in order to get it into a better form for certain algorithms. And it then goes on to try out multiple different algorithms and do automatic model tuning or hyperparameter optimization across all of those. It can do up to 50 training jobs for you, and it will produce all of those models, and it will visualize how they rank in terms of your metrics that you're interested in. So here, instead of spending maybe a few weeks, or maybe a simple model might only take you a couple of days, now in a couple of hours, you've got a model that's probably better than the one I could produce anyway, because it's got all the best practices all built in. And you get these metrics for all of them. And as I mentioned, a generated notebook, so you can see exactly what's been done. Extremely powerful new capability. So it's going to save you a lot in terms of productivity. But the other big thing is that I'm sure a lot of you have a big backlog of data sets that you'd really like to do something with. Well, now you can go after it with a really low investment instead of hiring an army of new PhDs. From the console, you'll be able to just say, here's my data. Here's the attribute I want to predict. Here's where I want the output to go, and you're off and running. If you're writing Python code, you can just say create AutoML job. And again, give it a job name, tell it where the data is, and so forth. Tell it what infrastructure you want to use. I want to use a cluster of 4 M5s. Tell it how many jobs you're willing to pay for, and off it goes. So that one is pretty huge. There's a new capability that's in preview. It's called Fast Start Shareable Notebooks. We already have hosted Jupyter Notebooks even before this week, which gives you less wrangling of environments to worry about. It's got all the popular packages already fully integrated and managed for you. That's pretty helpful. With this, though, you can start up notebooks in under 30 seconds. How many of you are using Jupyter Notebooks in SageMaker today? So you're probably not happy that it takes a few minutes to get them going, right? So a big benefit coming up there. But also one-click sharing. So if you're really deep into building your model and it's gotten to a certain point and you want to tell your teammate, hey, check this out, maybe build a different version for me, you can, with one click, share that, and it will understand all the dependencies and, that it needs in order to let them be up and running immediately with that notebook. And then the last one, from a cost savings standpoint, is switching instance types to match your workload. Let's say you're really working on some interesting and cool deep learning, and you need a P3 to kind of make you productive, to make things move pretty quickly. Well, that's great. You can have your notebook running on a P3. Your boss might be knocking on your door a few times because the expenses start to add up. And little does your boss know that half of the day you're not even doing training. You're going to lunch. You may be coming up with the next algorithm where you're just editing and viewing and analyzing data. So with the latest notebooks, you're going to be able to easily switch. So you can say, you know what? I've just did this training run. I know for the next 6 hours I'm really just going to be editing and so forth. Let me switch to an M4 and easily switch back and forth. That can save significant money. You could be saving at least 50% on Jupyter Notebook or SageMaker hosted notebook spend there. So this is a huge opportunity. And also experiment management. In a lot of companies, when you're really getting into some more complicated models, you might do hundreds or even thousands of different trials in an experiment. What experiment management does is give you a much more effective way to organize that, to share that, to visualize that, and to track the lineage of how did you get here. You want to be able to convince stakeholders the process that you went through, and this will help you do that. Here's a quick screenshot of after a few runs. I'm comparing a couple of them to see how the accuracy, let's say, or some, I think is accuracy in this case, is progressing across these two different training jobs. Speaking of training, let's dive deep in there. So here's how the training works. You put in your training data, you bring your algorithm, or you pick something that's built in. Maybe bring a TensorFlow script or PyTorch script into one of our containers. SageMaker starts up a job, and it spins up the instances and throws them away. If you weren't watching, you might not have seen that. So you're only paying by the second here, so the utilization really is 100%. So you're not worrying about, am I keeping my cluster busy? You're only paying for what you use there. And the artifacts get saved off to S3. Above and beyond that, so there's big savings on utilization, but you now, since this summer, have the ability with one click here, enable managed spot training. You can save up to 90% on your training job. So let's say you're about to go home for the day. You've got this 3-hour job that you want to run. You don't care if it ends up taking 6 hours because the spot instances might not be available right away or it might get interrupted. So hey, turn on spot training, save yourself 90%. Your boss will be quite happy. Here's an example where we had a 1-hour job. We only had to pay for 20 minutes of it. So that can add up if you do that enough. Also, hyperparameter tuning is built in. There's a very powerful way to get from a good model to a great model by using this. So from a notebook or from the IDE or from a CLI, you can launch a tuning job. We've got various tuning strategies that you can use. By default, it will use a Bayesian optimization. So it'll launch a couple of training jobs, see how they do. Those training jobs are each saving the metrics. So the tuning strategy will look, hey, how did those jobs do? Maybe I'll try a different set of parameters. and it will launch a couple more jobs. And those jobs will save their metrics, and this can go on. You can do as many jobs in parallel as you want, decide how many jobs overall you want to run. And in the end, you're going to end up with a set of models. And you can easily rank those and see, here's the best model, and the parameters you never might have dreamed up what the perfect parameters are going to be, so you can learn from that, and maybe you're a lot closer to production at that point. Instead of taking 2 weeks to iterate through this, pulling your hair out, you could just launch a job to get that done for you. Lastly, let's go through deployment. And this is where some even bigger savings can come from when you're using a managed service. And as you saw Andy Jassy say, you've probably seen in various other talks from AWS, the cost of inference really can be a lot bigger than the cost of training. You might think training is really expensive because maybe it's a distributed training, it's using a lot of GPUs, but when it comes down to it, a lot of the inference is going to be 24/7, right? So you're making predictions on demand. That can add up and become 90% of your ML cost. So you've got teams that are building models, and guess how much a model is worth if it doesn't make it to production? That's right, nothing. So you need some way to serve these models up to applications. So what are you going to do? Well, in most companies that I work with, these are some of the requirements that people will have. They're trying to build their own infrastructure for deployment. It's got to support multiple frameworks. We're not just all doing MXNet, let's say. It's got to support batch, deep learning workloads with things like elastic inference to be able to reduce the cost. You've got to have full security in there as well and auditability. And sure, make it one click as well. So the question for you, is this what you want your data science team working on? So let me show you a picture of a data science team I was working with late last week. Drum roll. There we go. So that is what we call undifferentiated heavy lifting. So this is not data science. So if you don't want your data science teams building these things out, SageMaker gives you what's called an Amazon SageMaker endpoint. So if, in this case, we wanted 8 instances to support the model. So behind this one endpoint, it'll automatically spread those across multiple availability zones. Also, if your demand really is variable, maybe between 10 and 2, you get huge spikes of demand, you can do auto-scaling as well. And so that will scale up and scale down automatically. There's also A/B testing. So if you've got version 2 of the model, you want to send some of the traffic that way, and then cut off version 1 at some point when you're more confident. That's all available as well. And really quickly here, in certain use cases, you can end up with hundreds or even thousands of models that each have their own endpoint. And that can get expensive. So if you've got a pricing service across different cities, some legal application maybe that's looking across different jurisdictions, or maybe you've got a per-user marketing model or per customer. You're trying to predict the next best action or next best offer. So if each of these has its own endpoint, that can be big dollars. So in this example, we've got 10 endpoints. That might cost you a few $1,000s a month. Multi-model endpoints from SageMaker lets you put these into one endpoint and just indicate which model you want to predict against. So in this case, it's down to a few $100s a month. And here's how it works. You put your models into S3. You spin up a multi-model endpoint that knows about that location. The clients come in and make predictions. SageMaker will automatically load those models as it needs them. You can add other models. And if a prediction comes in for that new model, SageMaker will load that as well, and all under one endpoint. The last piece I'll go through before I hand it over to Mohammed is monitoring models into production. You heard this in the keynote, I believe, yesterday. And this can be a huge deal. So if you've got models in production, you need to understand how well they're performing. Is your data changing significantly enough where you need to retrain? Are your predictions changing from what you expected? So model monitoring, you've got the standard process of training, producing a model, producing an endpoint. And what model monitoring lets you do is tap into that stream of requests and predictions and save that automatically. So it will sample that, save it off to S3. And then you can do monitoring jobs. You start by baselining what your original training data looks like, so you know the data distributions. You schedule a monitoring job to watch that data as it's coming through your endpoint. And then it will produce violations based on whatever thresholds you set up. And you can automatically get notified of those, visualize those in notebooks, and then make decisions to change your model or do some retraining. Very powerful. It can be quite painful to build this on your own. So big savings there, as well as managing how frequently you do retraining, so you can reduce the number of training jobs as well. So let me close before I hand it to Mohammed with a summary of TCO savings. So here's a few scenarios that we've looked at. And if you look across these, you could be saving anywhere from 50 to 96% compared to managing your own environment, as well as some productivity gains as well. So let's hear from Mohammed about some real workloads that are in SageMaker and how that has helped Aramex.
Thanks, Mark. Hello, everyone. I'm Mohammed Jamal. I'm currently head of data science at Aramex. I've been very fortunate to be in data science for more than 10 years and got opportunity to work in diverse domains ranging from aviation to energy to telco, ride sharing, and in the latest, logistics. So last year, I got the privilege to join Aramex, and there I got the opportunity to build data science team from scratch. So today I'll be talking about how at Aramex we are driving digital innovation using machine learning and how we are using SageMaker to accomplish our goals. Let's start with a brief introduction of Aramex. So Aramex is a leading logistics and e-commerce services company in Middle East and globally with its operations spanning in more than 60 countries and having more than 18,000 employees. Last year, we delivered more than 100 million shipments to 37 million unique customers. So at this scale, and being a logistics company, what's most important for us? So two things. One is customer experience and our business operations and processes. So in order to improve them, Aramex embarked on the digital transformation journey. So these are the 6 key pillars of our digital transformation. Some of them, as you can see, like core modernization and ERP enablement, they are specific to Aramex, and this aims at improving the overall technology stack at Aramex and helping Aramex adopt better digital tools. Some of them, like customer journey and last mile transformation, is about improving, is specific to logistics domain. And like last mile transformation is about improving the last mile processes in order to improve overall productivity. And last mile constitutes more than 30% of the overall delivery cost. And some of them, like leveraging big data, ML, AI, and cloud computing, is truly disrupting across the industries, and we are seeing it. So we are also investing in it. So why are we moving towards cloud? Basically, we want to iterate and innovate fast. That's the reason. And why do we want to invest in big data, AI, and ML? So let's have a closer look at this. So to illustrate this, let me take an example. Let's say James, he lives in Dubai, and he wants to order a gadget from New York for an event. So what's the first thing which he wants to understand? Or know? He wants to know when the shipment will reach him. And that's where the transit time prediction model kicks in. Next, he wants to know what custom he has to pay since the shipment is coming across the border. And that's where the custom duty prediction model kicks in. Similarly, once James places an order and the shipment is picked up by Aramex, then we have to take the address. We have to try to understand what are the areas, districts, what are the latitude and longitude, and all those things. This will help us in overall improving our middle mile. That's where automatic sorting comes in. And once the shipment reaches the destination city, then we use route optimization to overall improve the delivery performance. So the scale at which AI and ML is disrupting the organization is far-reaching. And in order to deploy these AI solutions, we require a robust data lake and an ML platform. So let's have a look at overall solution architecture at Aramex. So our data sits in Microsoft SQL Server on transactional database. And from there, the data gets replicated in S3. And from there, the data is populated inside Aramex data warehouse, which is on Redshift. Also, for low latency data retrieval requirements, we have DynamoDB. And our overall model training happens in SageMaker. And the model gets deployed within SageMaker endpoints. And then we create a Lambda to connect and invoke those models. And then we create it to API gateway so that the models can be utilized in the downstream applications. Now let's focus on the ML platform. So the first thing which we want to understand is, like, why did we choose SageMaker? So Mark touched on many of these points, but I'll just briefly recap some of the things which was important for us. So in order to answer this question, we have to let's think what are the key challenges which we face when we are building an ML platform. So the first thing is the choice of hardware. We need to choose what is the specification, like how much compute memory, or how much compute you require, how much memory you require, how many GPUs, how many clusters, and so on. The next is we worry about underutilization, or we worry about our data scientists sitting idle and waiting for their jobs to be picked up by the queue, or worst, they are chasing for approvals to prioritize their jobs. Once the jobs gets picked up, we also see that the teams are trying to debug and solve for package incompatibilities, version issues. And finally, once the model gets deployed, we have to ensure that we are having consistent latency, and we are also having optimal utilization of our resources. And finally, we do see that we have to a priori invest in our DevOps engineering team so as to manage and spin up the clusters. So on the contrary, what we want is we want to enable our data scientists to iterate fast and in a cost-effective manner. So let's try to see how SageMaker helped us solve these challenges and achieve our objectives through some of the use cases. So let's see transit time use case. So here, we are trying to predict when a shipment will reach the customer. There are various factors which affects transit time. Namely, let's say origin, destination, city, and country, weight of the shipment, size of the shipment, product type, payment type, is it a cash on delivery, and so on. And eventually, we use all of these factors to try to predict when the shipment will eventually reach the customer. So I will talk about 3 phases: build and train, deploy, and scaling of the models. So in a traditional approach, the way we would have gone is we would have tried one experiment, like let's say building a model on XGBoost, and then trying to we try to get the results, and based on the results and learning, we'll try another experiment. And we'll keep on repeating this exercise. On the top of that, if our resources are shared, our team may have to wait for their jobs to be picked up by the queue. So overall, this process is quite slow, and also we may hit hardware limitations. So if we want to run a deep learning model, and if we don't have a GPU, the team will be stuck. So what we did was, using SageMaker, we built our own experimentation framework, which enabled the team to run multiple experiments simultaneously. So let's say if we want to try the tree-based model like XGBoost and random forest, we can try a batch of those experiments. We can learn from them, and then sequentially, we can move to another batch of experiments. So using this, we were able to try multiple algorithms. We were able to try multiple, we did feature engineering. We try multiple sets of training data. We tried multiple model architecture for deep learning. And eventually, this entire experimentation framework helped us in taking the building and training in a much shorter span of time. Also, since we are using containers, we were able to use optimal instances for the jobs. So if a job requires a GPU, we can fire a container, a GPU-based container. And similarly, if we are just doing something like clustering or normal tree-based model, we can fire a scikit-based container. The next is deployment. So using SageMaker deployment was very seamless. So once we train the model, we get the model tar.gz file. We simply deploy into SageMaker endpoint. We connect it we create a Lambda to invoke those endpoint. We connect it to API gateway, and off we go. We have a fully functional API ready to be consumed by the downstream application. So after deployment, when we are thinking of scaling the model in production, what are the key things which comes to mind from a hardware perspective? So there are two things. One is the hardware specification of the instance of the server where we are deploying the model. And second thing, number of servers required. So again, in SageMaker, we were able to use the auto-scaling feature. So you can see the first graph. The blue line shows number of SageMaker invocations. And you can clearly see we have peaks and troughs. So using SageMaker, we were able to configure auto-scaling, and it avoided us to provision our servers for max load 24/7. And that gave us a flat 30% cost saving. On the top of that, we had the flexibility to change the instance type. So we started with ML5 X large instance, you can see in the bottom graph. And we realized that if we move from ML5 X large to ML5 large, the effect on latency was not significant. But we had a significant cost saving by changing the instance type. And this was very easy and seamless using SageMaker. This is how the overall model architecture looked like. So we have this is a deep learning model where we have three types of attributes. We have numerical features. We have categorical features as embeddings, and then time series vector as an LSTM. We combine all of them, concatenate all of them, and we have series of deep learning dense layers, and followed by a softmax layer, which gives the prediction probability. We were able to train, build, and deploy this model in less than 2 weeks using SageMaker. Without this technical capability, it would have been very challenging to achieve this even within, let's say, within 5 to 6 weeks. Now let's take another use case, address prediction. So here the objective is that we try to take an address and identify what are its streets, districts, areas, and finally, what is the latitude and longitude. This information helps us in determining the efficient route for the shipment, and also it is a key enabler for many other projects like route optimization, navigation, and sequencing. So let's see the overall. I think another thing is I want to highlight is that why do we need machine learning to solve this problem? Because in many parts of the world, this could be fairly easy to get all of this information. But in Middle East, the addresses are not structured. On the top of that, the names of the addresses are in Arabic, and people normally write it in English. So the number of variations are huge. So a word like Olaya, people wrote it in more than 50 variants. So that's the reason we require some of these techniques in order to decipher the address. So this gives the overall trading pipeline. I won't be going into the details of the components, but as you can see, these are color-coded. So some of them are compute-intensive tasks, some of them are memory-intensive, and some of them require GPU. So like language model. So in the language model, we are trying to learn the word embeddings using fast text, and which is a compute intensive. Similarly, in CNN model, we are trying to learn from an address the latitude and longitude, which is a GPU intensive. So, so we can see that using SageMaker, we were able to use optimal instances for optimal for the tasks, which helped us in significant cost saving. So we got more than 80% cost saving. And also, we had very significant time processing saving. So some of the tasks, which was taking more than 24 hours, we were able to complete it in less than 20 minutes. So overall, we clearly see that SageMaker has been phenomenal for us in empowering our data scientists to iterate very fast in a cost-effective manner. So I will end the discussion with a brief recap of what the team was able to deliver in a span of 1 year. So currently, we have 4 use cases under development. 5 use cases are already deployed in production, which is powered by more than 150 models in production, which is used for making 500,000 predictions per day with an average latency of 125 milliseconds. So hopefully, this discussion would have inspired you to give SageMaker a try. And hopefully, in the next re:Invent, I'll be in the audience learning from you all. Thank you for being with us.
Nice job. OK, thank you, Mohammed. So to wrap up our session here, I want to give you a quick call to action. So my main point is use that TCO framework when you're making these kind of decisions about what platform you want to deliver on. It may make sense for you to build your own. That's great. But think about the total cost, including how are you dealing with security and compliance, who's going to manage that environment and maintain it, and also think about multi-years, and think about enterprise scale as well. Machine learning can really fit into a lot of use cases across all different lines of business, so think big here. Also factor in the developer productivity savings for the data scientists and machine learning engineers, and try out a lot of the new features that just came out that are also big contributors to lowering costs. So with that, I really want to thank you for joining us today, and we'll be available outside for any further discussion or questions. Thank you.